So, hi all. I'm Sowndharya, as he said, and I am an iOS engineer from Zoho. 2 months back, my designer came up to me with this App Store-like layout for one of my app screens. On trying to implement it, I came across this new handy API in collection views, which solves the problem way more effortlessly than the traditional implementation. Now, with a little research, it just struck me that this API has much more to it than what seems. Which leads us to our today's topic of interest, the compositional layouts. Okay, before we move on to the concept, imagine building this layout along with me. What are our main goals here? First, we have the nested collection views because the layout scrolls in both directions. And then, each of the sections has its own distinct layout definition. Okay, our next goal becomes sizing the cells based on the content inside them. And lastly, but most importantly, each of the section has its own paging behavior. Now, enough goals now. How's the code look like? Obviously you're not able to interrupt it. I'll explain it to you. There's a huge chunk of code telling a collection view to sit inside another collection view cell for the paging behavior, and there is the targeted content offset method override for properly setting your pages, and so on. Each huge chunk of code for each of the goals I told you. Now, kind of pathetic, isn't it? Now, I want you to do this. Imagine building the layout, same layout, again along with me. But this time, just in 5 lines of code. Sounds impossible and amazing at the same time, right? That's what I'm going to show you today. So, please sit up. Let's dive straight in. Okay, what exactly was happening in those huge chunks of code I showed you? We were using something called the flow layout. What is flow? Flow is a line-based system. It renders the items one by one in the orthogonal axis, covers up the available space, and then drops to the next line. Simple and easy like that. Now, what are the possible layouts we can build using flow without much customization? Lists? Yes. Grids? That's what flow is made for, but what just happened when we tried to implement an app store-like layout using flow? Led us to the following twists. First, we had nested scroll views. Is it right? We don't know. Does it sound right? Most definitely not. And then while calculating the size of the cells, how much ever generic the layout is, under the hood, somehow we end up with some kind of hard-coded values. And for a layout as common as this, we write too much repetitive boilerplate code already. And to add to it all, every time I try to change the smallest CG float value in the corner of the layout, this warning keeps popping up. The height of the collection view, blah, blah, blah. Doesn't change the output, so why bother fixing it? Please don't tell that to my TL, please. With that, it's like, Apple finally concluded that modern design problems require modern solutions. And with iOS 13, Apple has introduced to us this brand new concept called the compositional layouts. What is this compositional layout? How does it help the developer? And in what way? So compositional layout is all about describing what the layout has to do. You pick small bits of components from your design, write code for them individually, and then stitch them together to form the overall layout. Now, in my view, this is another move by Apple towards a more declarative approach in programming similar to SwiftUI. It makes the application developer care mostly about the what of things rather than about the how of things. Now, compositional layout sits parallel to flow in the UIKit hierarchy. It is flexible, which you will witness in the examples that I'm about to put forth. It is composable, which is my favorite part because subclassing is such a pain when it comes to scaling. And it is claimed to be fast. Now, say you have a list view which you plan to construct using a collection view. Trying to achieve that using compositional layout requires these 5 lines of code. I know I'm asking you to do this instead of this, but I want want you to keep this in mind throughout the talk. The underlying strategy here is that the code does not grow as your problem gets complex. You can notice the pattern of 4 elements: the item, group, section, and layout. These are like the building blocks of a compositional layout. Let's have a visual take of this ladder borrowed from the dub session of this topic. This huge area is your layout. The boxes inside represent the sections. Cool. Usually in a collection view, the sections are populated with items. But here, we have an intermediator called the groups. Groups represent our rows. Not necessarily they have to be horizontal. This is just an example. And those groups are populated by items. Okay, fine. Now, in order to understand compositional layouts fully, you all need to know a few new concepts. I'm going to walk you through each of them one by one. First is the sizing. Now, how does the usual CG size work? You specify the width and the height in terms of CG float values. Kind of simple, isn't it? But compositional layout gives you a whole new perspective to how you size things. There is this new class called the NS layout dimension. What is it? It is an axis-independent way of specifying the size of an item. For example, instead of telling the size of an item to be an absolute width, you can do this. You can tell an item's width to be 0.5 times its container's width, and the item occupies 50% of the width of its container. An easy to reason concept, right? Same goes for the width. And one interesting thing to note here is that you can do even this. You can also tell the height of an item to be a percentage of the container's width. Okay, so layout dimension actually gives you 4 ways in which you can size things. One is what I told now, a fractional orientation, fractional width and fractional height. Third is the absolute one, as in a normal CG size case. And fourth is an estimated value. That's about sizes. Next in the ladder we have item. It's simple. It's a cell or a supplementary. There's much more to it in the SDK, but for now you can know it is initialized using a size. And then we have the groups. Now, groups are like the brand new concept introduced to collection views by compositional layouts. Those of you who develop with WatchOS will be familiar with this concept. Groups, okay, they are like the basic unit of a layout, the workhouse. They are initialized 3 ways: horizontal, vertical, and custom. You can think of groups like this. They are little mini flow layouts, each in the horizontal or vertical direction, like that. Now, we will have a look at groups in depth in a minute, but before that, let's have a look at section. As the name implies, it represents each individual section in a layout, and sections have one core concept that play a vital role in building our App Store screen in those 5 lines of code. Remember I told you earlier? That's a surprise, and I'll just tell you before the case study part. And our last item in the ladder, the layout, it's a UI collection view compositional layout. Not much to wreck your brains there. Now, you all can relax yourself now, and I can relax myself now, because all that theory is over. Let's just start with some coding already. Starting with simple list, as usual. Now, there is obviously the item, group, section, and layout hierarchy, but I put only the important part here. Notice the fractional width of 1.0. That tells you that your group occupies the full container. And since the item's width and the group's width are the same, each group is populated with one full item. Now, groups may seem a little exaggerating for a list layout, but I want you to pay attention so that we can move on to the next concepts graciously. In every collection view, we have the number of items and the number of sections count property. But with the introduction of groups, we have nothing like the group count property. Why is it so? Because groups represent an abstract repeating structure, a column of items or a row of items. Abstract, you won't be able to see them. Now, every time you specify a group as a parameter to a section, the group renders itself repeatedly until the number of items count of that section is exhausted. I'm going to repeat that to you. Every time you specify a section, a group as a parameter to a section, the group renders itself repeatedly until the number of items count of that section is exhausted. Let's look at it with an example. Here, let's say we have 4 items in a section, and we all know that each group had 1 item each, as in a list layout. So, the group renders itself 4 times in order to accommodate those 4 items. Say you had 2 items per group, as in a grid layout. Then the group renders itself twice in order to accommodate those 4 items. It's kind of simple. Now, that's about lists and how groups work in lists. What about grid layouts? Like I already told you, you don't do much. Instead of putting 1 item per group, you put 2 items per group. Simple, right? Or you can do even this. Instead of putting 1 item per group, 1 group per row, you can put 2 groups per row. Either way, the group is abstract. All you visualize is a grid at the end. You size your items accordingly. No. Enough of lists and grids already. Let's just have a look at how to solve our App Store's problem in 5 lines of code now. Okay, beginning with the first problem, estimated self-sizing. Remember the last option I gave you in those 4 options of NS layout dimension? The estimated value option? What's so new about it in compositional layouts? In a usual estimated sizing, both the width and the height of an item must be given proper estimations. But in NS layout dimension, estimated sizing works on a per axis basis. Oftentimes, you know the width of an item and the height may vary or vice versa. All that you need to do at the time is specify an absolute value for your width and an estimated value for your height. Simple, isn't it? The best application of this is while using labels which hold dynamic text. The height of the label alone expands and shrinks as the font size changes. Now, we solved that in just 1 line of code. Our next problem, the distinct sections problem. Each section has its own layout definition. Compositional layouts allow you to define section in 2 ways. 1. Just specify the section as a direct parameter to layout. Or use a closure that will be called back every time your section renders on a per section basis. All you need to do is customize your items and groups based on the section index property that your group gives you, that your section gives you, and compositional layout takes care of the rest. That must have already reduced tons of code for you, right? Okay, that's about it. We solved 2 problems, and there's one more concept, one interesting concept that you need to know about compositional layout before we move on to the actual examples, and that's nested groups. Okay, here. A group is actually a subtype of an item. What does that mean? This means that while building groups, instead of specifying items as parameters, you can actually specify a group as a parameter in turn to a group. Now, that opens us up to a number of immense possibilities. Imagine vertical groups inside horizontal ones and horizontal inside verticals, like that. In the layout I've put up here, each group contains 3 elements. The latter 2 elements are put into a vertical group, and that vertical group is given as a parameter to the entire container group. That's again a simple solution for a kind of complex problem that we face in our day-to-day design problems, not just for App Store's layout. Trust me, this layout which I've put up here, we all know it's a headache when we try to implement it, but when you bring in nested groups to its implementation, this becomes a cakewalk. Yes. And okay, fine. We've already utilized those 5 lines of code in terms of size, item, group, layout, and section. But we haven't solved our nested collections and paging problems yet of the App Store layout. Okay, fine. That was a lie. We have a 6th line. And remember I told you there is one core concept in composition sections that play a vital role in building App Store's layout? That is the orthogonal scrolling behavior. Okay, I don't know if it's orthogonal or orthogonal. It's Indian English. Fine. I'll leave the behavior part for now. Orthogonal scrolling, does that mean your layout, your sections now scroll perpendicularly to the scroll direction of your layout? You got it right. Your sections will now scroll perpendicularly to the scroll direction of your layout in just one line of code. Cool, isn't it? Orthogonal scrolling has 5 behaviors, 2 continuous and 3 paging. The last one, group paging centered, is what we use in our app store's layout. All 5 of them are beautiful, trust me. And that's about it. We've already learned we've almost covered everything about compositional layouts, and let's move on to the actual implementations. First was, as I promised you, the App Store's layout. As and when we were learning about compositional layout, we've already implemented App Store's layout. I've clumped 2 pages together so that you can imagine how the paging works. This is the entire layout. These 2 are your distinct sections. The first section contains a horizontal group, scrolls horizontally, and the second section lays out your items vertically and then goes up and comes down. So it's a vertical group. How you size your items for your horizontal group, it's simple. The item width is a fractional width of 1.0. And for your vertical group, you can also specify an item count property to a group. So we make use of that here. Fine. App Store's layout is almost like an obvious implementation of compositional layout. So what I did was, I challenged myself to implement the Pinterest layout. Okay, I wasn't able to do it. I took help from a friend. And how do you go about implementing Pinterest layout? Compositional layout allows you to implement almost all kinds of scrolling layouts. Here what you do is, this entire layout is comprised of 2 horizontal groups. And each group is made up of items that are vertically parallel. The height of the items are mentioned in absolute width. That's all. App Store, Pinterest, whatnot. Compositional layout allows you to build almost everything now. It's just very few lines of code, and that's about it. If you're someone who loves the art of breaking down, problem solving they called it, and you're already someone who loves building your UI using compositional layout, that's compositional layouts for you. Thanks to these 3 resources out of which I could pull a talk out of. Thank you all for being so patient. Thanks so much.